The velocity vector. If the position vector r is given by bt square I hat plus ct cube j hat, where b and c are positive constants and t is time in seconds here, when does the velocity vector make an angle of 45 degrees with the x and y axis? So remember that velocity vector is dr dt. So we take the derivative of the position vector with respect to time. It's dr dt. And when I take this derivative, I obtain bt square becomes 2bt I hat, and ct cube becomes 3ct square, so plus 3ct square j hat. And what I would like to have is an angle of 45 degrees with both x and y axes. So if I take the dot product of the velocity vector with the unit vector on the x-axis I hat, I obtain the magnitude of velocity vector v, magnitude of I hat is 1, cosine 45. So this should be equal to the x component, which is 2bt. On the other hand, when I take the dot product of the velocity vector with j hat, I obtain its y component, which is again v cosine 45, magnitude of velocity vector, magnitude of j hat times cosine of the angle between them, and this should be equal to vy, which is 3ct square. So I obtain 2bt equals 3ct square. 3ct square. So how is that possible? If I take this into t parentheses and collect all the terms on the left hand side, this is going to become t parentheses 3ct minus on the right hand side, okay, so 2bt goes to the right hand side, t parentheses 3ct minus 2b. This must be equal to 0. And that has two solutions, obviously. T is equal to 0, or when the time t is equal to 2b divided by 3c. So two possible solutions. One is the initial situation, t is equal to 0. The other one is when the time is equal to 2b over 3c. Okay, so we were given a position vector, time-dependent position vector. X component is bt square, y component is ct cube, because bt square is the coefficient of I hat and ct cube is the coefficient of j hat. And b and c are positive constants and t is time here. When does the velocity vector make an angle of 45 degrees with x and y axes? First I have to find the velocity vector, so I take a derivative with respect to time of the position vector. I obtain from bt square derivative with respect to time 2bt, and 3ct square from the derivative of ct cube with respect to time. The x component, v dot I hat, is 2bt. It is magnitude of v, magnitude of I hat, cosine 45. The y component is 3ct squared, which is magnitude of v, magnitude of j hat, cosine 45. And since these two are the same, 2bt must be equal to 3ct squared, and that gives me two possible solutions, t equals 0 or t equals 2b over 3c.